So what we're going to do tonight, then, we will find some peace, maybe some quiet, or at least we'll find some creative moments, because it's about time, everyone. It's about time we create life on this potato of a planet that we've made so far. No lake effect here in Cincy. 60 to 70s by day, low to mid 30s some nights this past week. Yep. Yeah, because you're on the other end of Ohio. So, congratulations, everyone. We've made a universe. We have made a galaxy. We have made a solar system. We've made a planet. And we have made primordial ooze. Yes, primordial ooze. Thantos, you have a lot of wineries around where you're at in southeast Washington. And, well, I mean, we're talking about the effects of weather. We're talking about the climate the climate effects at any point in time, and what is good to foster life. And I think that's a very good. That is a the ooze, like in kind of. It is mutagenic in a sense. It is making life from a pool of chemicals. It is changing the composition of things. So it's not too far off, even if it's not as fun and cinematic of a process, or as immediate a process as it is in Teenage Mutant Ninja Turtles. Add sheep, the primordial ooze. Capo says, I'm chock full of wineries here in southern Australia, some 10 minutes from my house, and one of the world's most award-winning Shirazes is made 30 minutes from my house. Yeah, I forget, there's a particular type of grape, I think, that does very well down in Australia, and is used in many Australian wines. But Australian wines are absolutely shipped globally. I could go to Kroger, well, they're closed now. I could go to Kroger and find an Australian wine. So I forget the name of the grape though. But Capo, if you want to shill for Australia and their wine, you're welcome to do so if you want to drop a name brand. And for any of you who are wine drinkers, you're welcome to list your favorites as well. All right, so how are we going to get plants and animals? Well, let's take a look first at what constitutes simple plants and simple animals. And then what we can do is, if we got to take a step back and get there, let's at least have a point of understanding. Pardon me. Let's at least have a point of understanding. So this first article, and by the way, let me say that the topics we're going to cover, this has been my standard disclaimer, okay? The topics that we're covering in building a fantasy world, I am often grossly simplifying the concepts. So if any of you out there have a particular specialty by way of your education, your training, your employment, I think I already said education, sorry. You are welcome to add detail or context above. What I am trying to do with this is to make sure I'm conveying enough information for you all to consider, to dig deeper into, or to springboard off of in fantastical ways that do not have to reflect our real world, because we are making a fantasy world. So you don't need doctorates in multiple disciplines in order to create a fantasy world. So the ideas I'm presenting are put in a particular order and they're simplified to keep them digestible and accessible. And if there's more that you want to look into, oh. Thank you very much, Camp Custom. We're squared up for that. Thank you very much. I appreciate it. And I hope everything arrives to you in good order. Shipping GGGGGG. Oh, Jurassic Spark. All right. Well, hey, get some sleep, my friend. And thank you for hanging out as long as you did. I promise we'll try to approach the Jurassic era. I don't know if we'll get there tonight, but something's going to happen at some point in time, all right? And it'll be completely up your alley, my friend. I didn't think I was going to make that noise. Beatbox and champ. Hey, happy accidents, Camp Custom. Happy accidents. You trust me with all right, thank you for trusting me with primordial life on our fantasy world, Jurassic. I will carry things on, and I hope with chat's help we're going to create some amazing things. All right, let's take a look at the articles. Woohoo! We have land plants to thank for the oxygen we breathe. And now we have a better idea of when they took to land in the first place. While the oldest known fossils of land plants are 420 million years old, researchers have now determined that pond scum first made landfall almost 100 million years earlier. This is important for what we're going to have coming up, okay? This study has important global implications because we know early plants cooled the climate and increased the oxygen level in the Earth's atmosphere. Conditions that supported the expansion of terrestrial animal life, says Tim Lenton, an Earth system scientist at the University of Exeter in the United Kingdom, who is not involved with the work. For decades, biologists have been trying to come up with a reliable birth date for land plants. Lacking backbones and hard shells, pardon me, plants leave relatively little behind in the fossil record. So researchers suspect even the oldest plant fossils don't represent the first flora. Some scientists have tried to use plant genetic data as molecular clocks. Knowing a typical mutation rate, they can estimate how long ago various species split based upon their differences in DNA. Ah, that was the stuff that we were learning about last night, right? To figure out their evolutionary history. But they have been unable to sort out the lowest or earliest branches of the plant family tree. At that base, vascular plants, which include the trees, crops, and flowers we are most familiar with, came along sometime after liverworts, hornworts, and mosses. Yet the order in which those three other groups appeared has been a mystery and has stymied molecular clock studies. Philip Donahue thought that if he brought enough computer power to bear on this problem, he could solve this mystery. Donahue, a paleobiologist at the University of Bristol in the United Kingdom, and his colleagues started with previously collected genetic data on more than 100 plant and algal species. They tested every permutation of the relationships of the four groups of plants with several kinds of these analyses and factored in the ages of dozens of plant fossils as a reality check. The exact configuration of the base of the plant family tree doesn't matter to dating the first land plants, Donahue and his colleagues report today in the Proceedings of the National Academy of Sciences. All the analyses indicate that land plants first appeared about 500 million years ago, during the Cambrian period. Well, what about the Coheed period? Come on, are we... maybe it was before they got together. When the development of multicellular animal species took off. The new analysis shows that the first land plants arose earlier than we thought, regardless of current uncertainties about which land plants evolved first, Linton says. Donahue's team... Boy, no laughter in chat. I don't want this to be a boring... I don't want this to be a boring lecture. I promise. We're not in a college course. You don't have to take notes. You can chew gum. You can pass notes to each other. You're allowed to laugh. Even if it's a bad joke, you can go, oh, that was a really bad one. Come on, dude. And I guess as long as I'm amusing myself. Hello? Is this thing on? Anyway. Donahue's team has also applied its computer power toward resolving these uncertainties. Plant scientists once considered liverwort the most primitive existing plant because it lacked roots and pores for gas and water exchange. But a few recent studies had suggested that liverwort-like plants were not the earliest land plants. Donahue now agrees. Liverworts are most likely related to mosses and once had roots and pores but lost those traits over time, his team reports this month in Current Biology. No, it's fine, Vampire. I appreciate it. The assumption has been the ancestral plant is physiologically like a liverwort, Donahue says, but his group's analysis suggests that ancestor likely had rudimentary pores and roots, and thus might grow better, process more soil and more carbon dioxide, and therefore have been more influential in Earth's biogeochemistry than researchers have thought. It's nice to see they came to the same conclusion that we did about liverworts, says Jim Liebensmack, a plant evolutionary biologist at the University of Georgia in Athens, who helped gather the data Donahue used for the new analysis. Liebensmack also praises the study that calculated when land plants appeared as the most comprehensive to date. If Donahue's results are right, this changes the entire timeline for the origin of terrestrial life and the subsequent pace of evolutionary change in plants and associated animal and fungal groups. Says Pamela Soltis, a plant evolutionary biologist at the University of Florida in Gainesville. Also, these earlier dates would mean that changes to the Earth happened at a slower pace than we might otherwise think. Liebensmack is still cautious. Molecular clock analyses always come up with older dates than fossils, he notes. So, quote, I always take these estimates with a pretty big grain of salt. Alright, why did I read this? Clearly, it's after midnight Eastern time, and you all needed to sleep. Oh, wall of text, 2 out of 10. What is this nerd stuff? I'm here for geek stuff, not nerd stuff. What are we even doing? Why are we reading articles? I need a premise that has more credibility than I do to work from and present concepts. So thank you for humoring me. I need you all to show that I'm not just going to be making stuff up out of whole cloth, partial cloth. We are going to make up stuff because this is a fantasy world, and we have a budget for an allowance for not having doctorates and having supercomputers calculating fossil records, okay? We need to know enough to be dangerous while we are coming up with our world. Now, this did talk about algae. And, well, this is a picture here of liverwort, what was considered to be the most primitive existing plant. Let's turn back the clock a little bit more, because this is a land plant, and to get a land plant, we need land at first for it to grow on. And I don't think we have that yet. And if you all want, we can watch the Q and Picard clip again. But, you know, that's up to you all. It's not vital for tonight. So let's take one step back, because to have a land plant, we have to have land. Do you remember the jellyfish story from last night? When the anthropologist asked, you know, what's that rocky bit over there? And jellyfish was like, what? It's irrelevant. You know, everything is in the sea. The superior species, the jellyfish, we're here. That land stuff? Who cares? There's nothing there. Pardon me. There's nothing there. It's irrelevant. Algae. Oh, I'm sorry, Dark Druid. I was so caught up in reading the article, I didn't see chat here for a second. How to get life. A meteor containing mycelial life crashes into the planet, releasing massive amounts of the microscopic spores that eventually settle into the ooze. You're not far off from a direction we're going, Dark Druid, and even something that was brought up before. So, independent third-party viewers like Dark Druid have a similar concept to a direction we're going towards, for a consideration at least. Does remind me of some of the things I remember from bio classes and dinosaur class. Well, when comparing current high-end computers to first supercomputers, we do have supercomputers. Sorry I missed last night's due to Coffee Cat's VTM. I'm glad you liked the article. I do want to make sure that, you know, I'm not just talking out of my spore, okay, everyone? Or my pore. I'm not just talking out of my pore. Because I need to establish some baseline considerations. We need to have a basis in a presumed reality before we extend that or extrapolate that into a fantastical outcome. So, bear with me, because we need to learn a little bit about algae. Algae. Did you know? Well, you know what? I'm going to save that for after we read about algae, okay? This isn't going to be another slog, although, I mean, Daly's probably nodding off in his chair. Just Algae, it ain't easy being green. And it's not, because after this, algae's not going to be so much green anymore, Vampire. So hold on to that thought. The fossilized remains of mycelium, a network of interconnected microscopic strands, were discovered in rocks whose age is between 715 and 810 million years, a time in Earth's history when life on the continent's surface was in its, on the continent's possessive, or plural possessive, surface was in its very infancy. And it'll certainly make sense why it's good to have an underground sensitive network, considering everything that can happen above that ground. So for right now, let's retreat back to the sea. Let's pretend that we don't have viable land just yet. Algae are photosynthetic organisms that possess photosynthetic pigments such as chlorophyll. However, they lack true roots, stems, and leaves characteristic of vascular plants. A simple plant like the liverwort. You remember the things that that lacks? Okay. Some of them are unicellular, whereas others are multicellular. They may also form colonies. Most algae are aquatic. Others are terrestrial and may be found on moist soil, trees, and rocks. Some algal species form symbiosis with other organisms. For example, a lichen is a symbiotic association between fungi and green and occasionally, there's a word, blue-green algae. Algae belong to a polyphyletic group. This means that the organisms in this group are not necessarily closely related. From phylum, kings play chess on fine glass stools. right? If you know that. Do any of you remember that from biology? Kings play chess on fine glass stools. If you want to know your categorization. I don't know if that's changed since that was taught to me. Maybe it has. Biology is a continually evolving thing, right? Dark Druid says, fungus-like mycelial fossils with 2.4 billion-year-old vascular basalt. Basalt being I was about to say ingenious rock, igneous rock. Although it is rather ingenious in a sense how it comes about, but algae belong to a polyphyletic group. This means got that. However, they share a common feature. They are eukaryotes, capable of photosynthesis with chlorophyll as their primary pigment, but they lack other morpho-anatomical features common among vascular plants. The scientific study of algae is called phycology. Some references include blue-green algae. However, they are prokaryotes, and as such, other authorities do not consider them as algae. And some are just holonotes. I mean, that's, eukaryotes, some people holotes. The term algae is from the Latin alga, meaning seaweed. Which, right, where's our origins? We're in the water. We're in the sea. We are on the seabed. I'm not going to get into every part of this. It is here. It is here for you to read about. You can expand this concept, but I needed to take us from early terrestrial plants. We're going to go back to the ocean for a bit. Let's get some ideas on these very simple structures, because from simple things, we can build complex things. And then we'll come back around and we can start talking about complex things. Eukaryote says, not often. I don't often carry karaoke, which means empty orchestra in Japanese. Of course, we corrupted it to karaoke, but it's karaoke. So we have green algae, red algae, brown algae, golden algae, and there's even... Man, there's this weird blue-green algae. They're not considered by other references as algae since they're prokaryotes. Nevertheless, they are similar to other algal species in being photosynthetic due to the presence of chlorophyll. Aside from this pigment, the blue-green algal cell also has phycobiliproteins that make them blue-green in color, thus the name. Oh, my goodness. You mean that there's one step from the simple algae? Well, there is. Look. We have a eukaryote, and now we have the prokaryote. What's one step? If we were to change one thing, it's a couple, but there's a flagellum? Oh. Interesting. A rounded shape, spiral. We're seeing some patterns of things. There's a DNA nucleoid. Membranes. Man, we're bringing up all of the biology here, right? A prokaryote refers to any of the group of living organisms primarily characterized by the lack of a true nucleus and other membrane-bound organelles, such as mitochondria. Do you all remember mitochondria? Now, of course, we were talking about even midichlorians, because at some point, where are we going to want magic? Whatever magic is in this world, what do we want it to be? How is it going to interface with things that are living or not living? Anyway, we have mitochondria, powerhouse of the cell, as you all may know, and chloroplasts. And by the possession of a single loop of stable chromosomal DNA in the nucleoid region and cytoplasmic structures such as the plasma membrane, vacuoles, and primitive cytoskeleton, and ribosomes. Examples of prokaryotes are bacteria and archaea. Hey, Crispy, welcome. Mitochondria loads up Parasite Eve on the PlayStation. Yeah, we had wait, right? As science was coming out with things, pop culture was in its wake, and mitochondria became a thing. We also dinosaurs was a big movement. We had Jurassic Park and everything. We had nanomachines, which are kind of a mitochondrial. As these things come out through conversations and scientific researches, that goes into sci-fi, could bleed over into fantasy, that goes into other things, and we have these big cultural movements around it too. Now, I'm not going to get into everything here. You can read about this if you want. I'm going to, if you want to read about what is a because this is that blue-green algae. This is that next step where it's not quite algae, but it's algae? Question mark? Not really. Cyanobacteria, any of a large heterogeneous group of prokaryotic, principally photosynthetic organisms. Cyanobacteria resemble the eukaryotic algae in many ways, including morphological characteristics and ecological niches, and were at one time treated as algae. Hence the common name of blue-green algae. Algae have since been reclassified as protists, and the prokaryotic nature of the blue-green algae has caused them to be classified with bacteria in the prokaryotic kingdom Monera. What does all this mean? You can read about this. You can read about cell membranes. You can read about chlorophyll. You can read about what it does with nitrogen. This and ways that we have come to even use this as a tool. And of course, hey, Big Slam, it's been a minute. Good to see you, my friend. And I was going to say, we've come by in modern technology using algae for all kinds of stuff. I think there was now this is conjecture based on memory. I think there was some exploration in a type of algae that can be turned into plastic. Algae that can be used in all kinds of organic farming methods. Of course, algae that is used in other ways for direct or indirect food production or consumption. I think it's a bacteria, not an algae, that can break down oil spills and even break down plastic. I think it's a special bacteria that was made. And there was something that blew up on Twitter a little bit about having an algae tank in a city to help absorb carbon dioxide. Strip the carbon out, as it's got to use carbon for making more of itself, and then it releases oxygen back out into the atmosphere, acting like a tree. So there's a lot we are still learning and can employ and use in our own lives, as technologically advanced as we are, as the cutting bleeding edge of species on the planet. So says a very species-centric set of disciplines. That we can go back, and there's a lot of things that can be done with these simple structures. Oh, Big Slam, I hope things are either stable or better for you, and that your the weight loss journey that you've been on has been good, and everything's getting taken care of what needs to be taken care of. I'm really glad that for it all, Big Slam, that you found some time to pop in and say hi. And you're welcome to talk and lurk and participate. So we have algae. That's that one next step from algae, right? Now we have this blue-green algae because the chemicals inside are a little bit different. The structure is a little bit different. We've taken one step away from a very simple organism of algae, and we've added blue to it. And now we have blue-green algae, which is a cyanobacteria, which is closer. It's classified alongside bacteria which are more in the animal side of things, right? So little steps. This is what I want to highlight. This is the type of thinking. Well, thank you for lurking and for saying something, Osric. That kind of chat activity is always welcome. Also, WJ, thank you for the follow. I don't know why the alert box didn't go off for it, but thanks all the same if you are lurking out there, WJ. So, they do things with nitrogen, they do things to move, they do things to reproduce, they do things that are a little bit different than algae. They do things that continue turning into other things, including, and I'm going to pop over real quick. If we go back, if you see, there is some moss and lichens growing on the rock in the foreground, in the lower right side. And almost anywhere you go, I'm sure you're going to find rocks, at least rocks that haven't been moving around a whole lot. You're going to find growths like this. And this is going to continue. I'm not going to get too far ahead, because we also have other types of alga. If any of you have heard of red tide, and I'm not talking about University of Alabama, I'm talking about the blooms that happen in the Gulf of Mexico. So if any of you have heard of the red tide as an algal bloom, then this is it's another type. Now, this is a particular species, but of course, this is different. In fact, this species is... Uh-oh, we're being raided. Hold on a moment, everyone. Let's jam out a bit. Welcome, Raiders from Single Step Gaming. Welcome, Brufros. Good to see you here. Black Kevin is also raiding in from Single Step. Thank you for doing so. Daily, if you're not asleep at your desk, can I get a shout out to Single Step Gaming? And Ari Cypress Everly, welcome to you as well. And thank you, Rosewolf, for the jamming out emotes there. Welcome, everyone. We are populating our space rock with life. Well, we're getting there. We're discussing very simple early life, and then we are going to get to that point. Okay. So, do red tides occur anywhere else? Yes, many algae species cause red tides all over the world. Yet the organism that causes Florida's red tide, K. brevis, is found almost exclusively in the Gulf of Mexico, from Mexico to Florida. Florida red tides can be transported around the Gulf of Mexico as coastal waters move with winds and currents. Some red tides have even been carried by the Gulf Stream current into the Atlantic Ocean and as far north as Delaware. Early life like grade school drama, right? We're going back even further. There's still drama, I assure you. Maybe not grade school. Let's give you a shout out, Single Step Gaming, and a shout out, Single Step Gaming. There we go. Got you covered, my friend. Thank you for coming over. I hope your D&D game was going well. And thank you for joining us. So we're talking about liverworts, but even before that, because this is an early land plant, we gotta go back. We gotta go back in time. All right? Because this is it's nice having land plants, but you got to have land for the plants at all, right? And so we looked at algae as it was growing at the bottom of the ocean. And then we took one step beyond that and said, what if algae did a little a little wiggle and got a new feature, right? Got a little bit more complex, which led us into blue-green algae, and we could talk about the rise of bacteria, but not just yet. Hold on, we're getting to animals. Diatoms, things that would, if any of you are familiar with diatomaceous earth, if you want to know where that comes from, then there you go. It's fossilized, microscopic, like plant life. Very good for non like chemical bug control. Anyway, so algae. This is where we're starting, and why are we starting here? Well, as I said, we might be skipping a couple steps. I'm here to give you enough information to be dangerous. Okay. But let's go to our sketch pad here. You ready? In the beginning, we have water. Dun dun dun. Oh, hold on. I know that this is things are going all right. For bug control, I like doing the natural and unnatural for a 1-2 punch to make sure they dead, says Brufros. Now, we were talking about maybe life originating around underwater vents, volcanic vents and such. And, well, no, xenomorph. If a xenomorph can operate out in space, I don't think diatomaceous earth is going to work on them. But you know what? Let's create some land. Maybe some continents bunk into each other. Maybe we have a volcano just sort of erupt out of the water. But I'm getting the feeling that we need a land mass somehow. Okay, and so we're just gonna go bloop 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 bloop. Okay, this is a primordial ocean. It is, it's pretty harsh. We have a volcano here. We are just going to be spewing gases and elements and all kinds of things. Of course, the island is going to grow from this. We are also going to get interesting, funnily enough. We're almost making a Bermuda here, everyone, okay? If any of you wanted to take a vacation in Bermuda. The reason their sand is pink is because of a bacteria in it. So we're having a fun little life experiment, okay? Well, this volcanic island continues to grow. Things happen. This is a geological time period, so, we're skipping ahead a couple million, maybe a couple million years at a time, Some erosion happens, some things just break. There could be a geological activity going on. Our volcano is on and off, spewing gases, stuff is bubbling up, it's churning things. We have a source of heat, we have a source of chemicals, we have a source of motion churning things. And, at some point, because we did say that there is a primordial soup. And if we're going to create a bowl, let's say that for some reason our bowl of primordial soup is more something like, you see how we got these spots here? Well, some lava comes down, and maybe this becomes a little bit more attached here. And even, something happens and this is connecting. I don't know. Again, we're traveling through time. We're seeing things take place. And now we have a fun little sheltered area It's still churning. There's still tides. There's still things. But now we have our little primordial soup area. And for purposes of what we're doing, why don't we make it a nice light green in color? Because we don't have grass yet, and I just want to make sure we know this is our active zone. Kaihira, welcome to you. How long did life exist on this planet before the first great cataclysm, nearly eliminating all living things? We have talked about that. Things might have happened. That the first strands of proteins could have been formed, and then who knows? Lightning struck it, and then we had to wait 1 million years for the right conditions again. But that did come up in conversation. Hi, Dry Gold. Hard to say. That's either oxygenation or oxygenation or cryogenian. Brufus says, I'm getting sleepy. Been really a long week. All right, be well, Brufus. Thank you for coming over in the raid. Well, we have tides and winds and lightning strikes and volcano stuff, and oh my gosh, a lot of things are happening. And also, it's a little rough if you want to have life being dashed against the rocks, being broken apart. So as our primordial ooze is churning, it's doing whatever it's got to do. We're getting close to maybe algae forming. In the meantime, what do we need to do? Yep, that was brought up, Kaihira. That's why we talked about perhaps a volcanic vent underwater, like the chimneys and such. Well, what we're gonna do, we're letting the soup warm itself, right? We've created the pot, we've thrown in the ingredients, and we're gonna let it do its thing. Now we need to set the table for life, and part of that. Why don't we bash some rocks together, which could free up some elements to churn around in the soup. But let's keep bashing rocks together, eroding it with wind and such, and at least make things... let's make a lot of big, tough rocks into a lot of smaller, softer rocks that even our microorganisms that are going to crawl out of here can wiggle between, use for shelter... and go from there. So, and by the way, Kaihira and anyone, you are always welcome to put fun facts and other info up here. Again, I'm spouting out ideas enough to make a coherent story. I want to have you asking questions or doing the research to become even more dangerous than what I'm helping you to become. So don't stop bringing that stuff up or theorizing. Well, now we have a bunch of this stuff called sand, because over millions of years, we've been able to grind down our rocks. Excellent. And that might even lead to some smaller rocks. That might even lead to our bowl, unfortunately, breaking, and now the tides are surging. But now we have some kind of an algae. We have some things that are able to move... not onto land, but through the water into land, and sometimes they might be left to dry, or at least try and stay wet enough until the tide comes back. But we're there. We have this halfway. 2, Dark Druid. 1 is geostationary, and that'll get into a conversation about how gravity can affect the life forms. And other such things. Well, now we have this intermediate area, and now we're getting algae that is sometimes on the land, sometimes not. Unfortunately, the weak algae is going to die off. The strong ones are the ones lucky enough to stay in the sand, like just under the surface. When cosmic rays come down, when a volcanic gas that's heavier than air rolls down and over things, but it's not going to suffuse the water, or who knows what. But now we're spreading, and we have an adaptable form, and maybe even at some point a magic, radiation, gravity, who knows? Because this is a fantasy world. Something happens and algae gets a little wiggly do and is going to help it move around. It's going to get a flagellum. Or it'll develop, maybe a chemical comes down from the mists of the volcano. And it could very well have killed the entire colony of algae here, except for one. And man, was that one got exactly what it needed. It was hit with a UV light, it was hit with some radiation, it was hit with magic, it was hit with gravity from the moon, it got a chemical shower from the volcano, who knows? But that one got what it needed. And now it's a little bit different. It almost has that kind of an animalistic feature. A little bit of motility, or mobility. It might be a little bit more survivable. It changed its color because its chemical composition is different, because it's able to take in the chemicals that are there. It can survive. Have you? Yes, and the experiments with slime molds, Cyborg. It was very interesting. The one in Japan that planned out the railroad tracks. And this is where we're at, Cyborg. We are at that kind of single cell, very simple life, but is able to spread, is able to have a genetic knowledge of things, genetic behaviors, because we're slowly over time not only changing where they're changing themselves because of the environmental fact. Again, who knows the cosmic rays that are beaming down on them, or the chemicals from the volcano. And so the patterns might adapt over time. And now finally, if you remember the jellyfish story we read last night, and now finally, a land-based, still needing to be moist, but a land-based algae was able to survive above the sand, where it's nice and soft, laying out on the beach, exposed to the suns. There's 2 suns, exposed to the moons. It needs the water. It probably needs a shower of chemicals every now and again. But that's cool. We still got a couple million years, right? We're working on it. And now we have that very first algae. I'm going to draw it. I'll even make it purple just to stand out. You all ready? Hey, there it is, right there. Oh, it died. Ah, dang it. Now we got to wait a million years for this to happen again. Okay, are you done waiting? Cool. All right, cool. Now we have an algae that is above, and it doesn't die this time. We don't need to wait another million years. And a couple of them come up, and they say, wow, we really, really like it here. But as time passes, there's a baleful radiation from the creator gods, from the volcano, from space, from wherever. And some of these things die, leaving behind their elements, leaving behind their nutrients, their bodies, and other things. Well, they weren't the only little algae, as others come up behind them and go, oh, food? Sure. There's more stuff that makes us here? Yes, please. Let's eat it. And die. And then the next wave comes and goes, oh, let's eat it and die. And more and more and more, as now that the chemicals are spreading from our soup. Our soup is spilling by itself. Kind of like how the slime molds were working together in a colony. And now we are getting, boy, on our world, we have, maybe after 500,000 years, we actually have a patch of sand that is littered with the corpses of a million billion algal cells. However, that sand is rather rich in more of what is needed. So let's keep doing that. Now, of course, as this happens, there's more rocks that are banging together. There's more rocks that are banging together. And maybe the volcano's not exactly doing what it needed to do much anymore. Now, things have adapted since then. But look at all this great territory. Look at all this moist land. And maybe a couple of the algae are swirled around by the wind, or they have their little flagellum, and they just take forever. There's... you see what's happening here. Let's zoom in, shall we? We're getting the good stuff. Because now we have 11 billion algal bodies. And what this is doing is enriching this sand. More and more follow because there's more food and more footholds. There's more ways that you can hide from the cosmic rays, gain nutrients, even to bulk yourself up. Whew! We just dodged that last gamma radiation burst from one of the suns because we had enough of us to eat that we were able to survive it. And you know what? Those that didn't died off, and those who did are stronger for it and are probably going to survive the next gamma radiation, making them the Fantastic 4 quadrillion. Dark Druid says the first great cataclysm is in fact an impact of a rogue comet with one of the moons, causing its orbit to stop, shattering the comet and ejecting billions of tons of material from the moon, showering the planet for thousands of years with debris containing the spores, returning life-generating material to the planet after altering the magnetosphere, tilt, and spin of the planet. I have good news for you, Dark Druid. You are one you are one day early. So you are one step ahead. Because I promise you, we are going to have some sort of a threat and opportunity come from stuff exactly like this. So, the idea is not a bad one. We're not there yet. Now, we can use that as a foot in the door, because we never said, did the algae just happen from chemicals floating around in the water? Could it have been a piece of the moon? Could it have been the thread from the Parn book series? Could it have been something else? Possibly. We haven't defined that. All we know is that we have our soup, and our soup is starting to spill itself out of the bowl. So this is a very good idea, but I'm not quite there yet, because we got to get our early foothold first. At least in the way I want to present things. If you all are creating your fantasy worlds at home, don't let me stop you in that way. Okay? Don't let me stop you from doing exactly this. It's just in the presentation, I'm putting myself on rails. It's karma for me being a forever DM. I have to put myself on rails, okay, everyone? Alright, so things are happening, right? We have this island. Let's zoom back out. And now we're going to advance another, let's give it 200 million years. Well, now we probably have our volcano might not be a volcano anymore. I know, how dare it? How dare this volcano go dormant? Literally, what volcano does that? And now we have a lot more going on here. However, as the rocks continue to wear down, as things break down, as things get more favorable, because we have water, we have tides, we still have chemicals, and at this point, our algae has grown into from a eukaryote to a prokaryote. It has its foothold, and now we can find it growing in the shallows, not just here. Maybe other rocks have come up, or something happened, or it's just moved through the sand. And now, after years and years, and by that I mean maybe not billions of years, millions, hundreds, dozens, tens of millions of years, hundreds of millions of years, we have created, over the generations of algae, the conditions of life and death such that the land is suffused. We're going to make the purple zone. We're going to make the purple zone the algae zone, right? This is the land now where things can grow and thrive and survive more easily. Look at our real estate footprint. And from this, there's other plants that maybe they got hit by a cosmic ray. Maybe they fell from the sky and landed here, and this is a very good territory for them. One of them, boy, there was an algae and or a cyanobacteria, and they were having a bad day. They split and mutated in the split for whatever reason. Chemical, radiation, magic. It was the will of the gods, or God singular. However it happened, something different. Because maybe, what if during a storm, right? We have some low-lying rock here, because things have been wearing back down. So we have the top. We have our crater. So this is actually the peak here, since this actually goes down into the crater, or even the crater lake at this point. And then, we build out our volcano and our topography. It goes like this. Some things have crumbled over time. Here we have kind of a flatter spot. It gets a little wider, as things are actually traveling downward. And there's little pockets of things that might still, be taller or whatever. However you want to set the scale, set the scale. We're just having fun here. But something happened where maybe a schmutz, a sploosh, something might have blown, splashed, whatever happened. And what if there was actually a little pool of water up here that was even containing, it was containing some of this stuff. And we might not exactly have the sand, but the rocks are wet enough, it starts clinging. Maybe it's getting different minerals here or something. And then we start having, a different kind of, we have a different kind of life that is able to cling to the rocks or grow out of them. It's a little sheltered from the wind. And so this is its own second. We have our one bowl that's still pumping out life. And now we have this other one going. Now, mind you, this is just one small island. This could be happening simultaneously or on a geological scale simultaneously. Sure, this one might be ahead by 200 million years, but this one got 200 million years of starting, genes, splat into it over here. And they have a little bit of a head start. So it's still simultaneous, even though that got it going. And really, what's 200 million years in a billion years, right? You know what I mean? I hope you're getting the concept. This is some tongue-in-cheek stuff. I know we're passing over some steps. Bear with me. Well, things start going, and wouldn't you know, at some point in time, we have a jolly old reunion as we have a territory now between the pinks and the purples. Although, maybe instead of fighting, though they could, they might find each other delicious. They might also find each other very, compatible. Know what I mean? Compatible? Wink, wink, nudge, nudge, say no more. And we get something amazing. We get something different. And now there is a beautiful, rich place for, here, I'm going to change the color. And now, after all of this time, we might still have the sand. But now the sand isn't just lifeless. What if we actually have created soil on the corpses of 11 million billion pieces of algae, blue-green algae, the pink stuff, whatever the pink stuff is, besides what McDonald's was putting in their hamburgers, and whatever's come about through all the churning of water, gases, extraterrestrial interference through celestials, through just the cosmos, through comets and asteroids and stuff. And now, after the very first algae was floating around in the kiddie pool, right? It was very safe, nice shallow water or whatever. It could have been deep water too. I don't want to disregard that. But in this example, let's just pretend. And now, after, millions of years, as chemicals were seeping around, as they're slurping or schlepping or whatever else, they were getting around. They were mixing and churning. And now we go from lifeless volcanic rock, into something like soil. Because that's something a lot of us might take for granted. You can go to wherever, Lowe's or a local nursery or something. You can buy a big bag of soil for maybe $25-$30, maybe more because of inflation. And how lucky you are that bag of soil is the result of hundreds of millions of years of life consuming itself, dying, consuming the bodies, making more. $7.98. Well, I mean, is that for just like a couple quarts? I swear it was a lot more. If you want like one of the big, what is it, like 6-quart bags or something like that, Coffee Man? I mean, otherwise, if you're getting bags of soil for $8, like, you got to send me a message, my man. And not mulch. I'm not talking about mulch. I'm talking about like garden soil. And of course, on top of that, there's the artifice that we've introduced by already having nitrogen, the little pellets and things infused into it, or the convenience of the little styrofoam beads creating room for air to flow and everything. But now, after 200 million years or whatever, we actually have a thin skein, S-K-E-I-N, a thin skein of mostly dead, but also because things are eating and dying and they'll be eaten again, and we're going to recycle the nutrients. We're going to recycle the genes from the chemicals that have crawled out of our soup. On our island, we now actually have something like a soil. Now, this soil might not necessitate roots or pores, which means that we get a simple yet complex compared to algae and even cyanobacteria. If we go back to this, and then finally we have Liverwort, the most advanced life form this world has produced. This is the alpha and the omega. This is the dominant plant because it exists. It doesn't need roots because there might not be a lot to root in right now. It could just absorb the land-based goop or whatever. But check out this apex predator. Check it out. Oh, you know, you never thought perfection would look like this, did you, everyone? But now we have liverwort growing on our planet. And it's going to proliferate because there's an abundance of algae corpses covering the island. It was molded by it, shaped, but very much so, right? And from here, what do we get? I'm going to fast forward very casually, mind you. I'm going to fast forward another 100 million years. Mosses, basic fungi, the fusion to make something like a lichen, L-I-C-H-E-N. We're not at lycanthropy yet. Bear with me. That's a later lesson. Right? We get ferns, mosses, fungi, because each of these tribes are going to vie for territory, nutrition. They're going to eat each other. They're going to breed with each other. They're going to do both at the same time. Coffee Man says, Gonadur ruled that primordial soup. Got him, we all grew, and to him we all shall return. All hail the Slime Lord. Is that a Pathfinder god of oozes, or well, I'm not recognizing, or is that the goblin take on the ooze god? So, congratulations, everyone. We have populated our world with the advanced species of liverwort, and we now actually have an island. We should probably wear down this mountain at least one more, and we could recolor this. But we have plant life. The last thing to consider before we take a break, depending on the gravity of this world, that could change the shape. Now, while we saw in our real world one flagellum for prokaryotes, for the prokaryote example, what if we actually need two in order to get around because of the gravity, or because of the radiation from the two suns, or the moons, or the ring around the planet, or the presence of a god or goddess or pantheon, or whatever the concept of magic is? Life does tend to take the path of least resistance. Water and electricity do the same thing. It's a very elemental force. Can something with two tails come up out of a random mutation? Of course. But if it's not efficient, it probably won't stick around because it's more energy than what it's worth. Or it's just deficient, or something else hasn't changed that needed to be. Now, in this step, you can consider that. Due to the conditions of whatever, it could be the gravity, it could be the nutrients and the chemicals, it could be any of that stuff I listed. Maybe these plants, or if the gravity's lighter, what if they actually grow stronger, or grow taller, because they don't have to fight gravity as much? Maybe. If you just want to keep at Earth levels of what you know, do so. This is your fantasy world. And thank you, Travesty, for the subscription with Prime. And now, what are we going to do with our island? What are we going to do with our island filled with vegetation, such as algae, cyanobacteria, and liverwort, and ferns and mosses and lichens and stuff? Let's take a break and we'll find out. Everyone, take a 5-10 minute break, get up, stretch, and when we come back, let's talk about some early animals and get some early life on our planet, if only on this island. because we got to set up for our final workshop of the evening, which Dark Druid was talking about just a little bit before. So I'll see you in about 5 to 10 minutes, everyone. Also, hi, Tio.